Second situation, rotation. If we consider the disk shown in this figure, this disk rotates around a fixed axis passing through the center O in this figure. And if we take 2 points from this disk, A and B. Points A and B of the rotating disk, say, have circular trajectories. The center of rotation O remains motionless. It is a rotation. If we observe this figure, during the rotation of the disk, A describes a circle centered at O and of radius OA, and B describes another circle centered at O but of radius OB. When a solid is rotating around a fixed axis delta, the points of this solid located on the axis are stationary and the other points describe arcs of circle centered on the axis of rotation. So, A describes a circle of radius OA, but this circle is centered at O. And B describes a circle of radius OB, but it is centered at O. All the points of a solid in rotation, all the points located on the axis of rotation remain at rest, or all the points belong the axis of rotations are motionless. For example, in this figure, the point O is motionless, but A or B describes a circular path or describe arcs of a circle. So, all the points from a solid in rotation, all the points located on the axis of rotation remain motionless or remain at rest. And the other points of this solid on rotation describe arcs of circle centered on the axis of rotation, for example called delta. If we take in consideration this solid of irregular form in rotation around a fixed axis delta, and we take on this solid 3 points, for example M1, M2 and M3. M1 describes a circle of center O1 on the axis of rotation, and M2 describes another circle of center O2, and M3 describes a third circle of center O3. The paths of the points of a rotating solid are centered circles on the axis of rotation. O1 is the center of circle described by M1. O1 is located on the axis of rotation. And O2, the center of circle described by M2, is located on delta, so on the axis of rotation. And O3, the center of circle described by M3, is located on the axis of rotation. So the paths of the points of a rotating solid are centered circles on the axis of rotation, but having different radii according to their distance from the axis of rotation. The three circles has its center on, for example, O1, O2 and O3 located on the axis of rotation delta, while the radius relative to M1 is different from the radius relative to M2 and different from the radius relative to M3. If we consider this cylinder in rotation around a fixed axis delta passing through its center O, and if we take 3 points from this solid and the 3 points are on the same radius. For example, point A is the first point, for example, M in this place, and the point N, for example, in this place. V1 represents the velocity vector relative to A, and V2 represents the velocity vector relative to M, for example, and V3 represent the velocity vector relative to N. N, M, and A are situated on the same radius from this circle, but the radius relative to A, or the distance OA, different from the distance OM, different from the distance ON. In fact, when the distance from the point M to the axis delta increases, and the length of the arc of the path is great, so the instantaneous speed is great. If we observe this figure, for example, V1, the velocity vector V1, has a length greater than the velocity vector V2 and greater than the velocity vector V3. Why? Since the distance from the center O to the point A relative to the velocity vector V1 is greater than the distance between the center O and the point M, for example, relative to velocity vector V2, and the distance from O to the point N, for example, relative to velocity vector V3. So, when the point M is very far or is far from the center, when its velocity vector or the magnitude of velocity vector increases. Thus, all the points of the solid does not have the same instantaneous speed value, even if their lines of action may be identical when these points belong to the same radius. For example, in this figure, the line of action of V3, V2, and V1 are parallel, while the magnitude of V3 and the magnitude of V2 and the magnitude of V1 are different. Why? Since the distance starting from O to the point N, for example, relative to V3, is different from the distance starting from O relative to point M relative to the velocity vector V2, and the distance from O to the point A relative to the velocity vector V1. So, if we have many points or 3 points, for example, of a solid in rotational motion, the instantaneous speed, the value of velocity, does not the same for all points, since the position of the point is taken in consideration when 2 points are at different distance from the center, so its velocity vector does not have the same magnitude. In this figure, if we consider now a cylinder in rotation around a fixed axis delta, and if we consider 3 points at the same distance from the axis of rotation, in this figure, we take in consideration 3 points situated at the same distance from axis of rotation delta, while in this figure we take in consideration 3 points located on the same radius but at different distance from the axis of rotation. In this figure, we consider 3 points from a solid in a rotational motion, but these 3 points are situated at the same distance from axis of rotation, or these 3 points are situated on the same circle of common radius. For example, if the first point is called A, this B, for example, and this point is called C. A, B, C are situated on the same circle. So, in this case, this is the velocity vector v1 relative to A, this is the velocity vector v2 relative to B, and this is the velocity vector v3 relative, for example, to C. If we observe this figure, we find that the length of velocity vector v1 is equal to that of velocity vector v2 and v3. So the magnitude v1 of velocity vector v1 is equal to the magnitude v2 and the magnitude of v3. While the line of action of velocity vector v1 is different from that of velocity vector v2 and v3. So, in this figure, since the 3 points taken in consideration are situated on the same circle, we obtain the same value of the speed. For example, v1 in meter per second equal v2 equal v3, while the line of action of v1 is different from that of v2 and v3. So, if the points are at the same distance from the axis of rotation, their velocities have the same value, but their velocity vectors does not have the same line of action. Line of action, this is the support line of the vector. The speed vectors are therefore not identical.